Hello viewers, welcome to our YouTube channel. If it's your first time coming across this channel, try to subscribe, like the video, and also leave a comment. Do not forget to share the video. So in today's tutorial, we are going to concentrate on dimensional analysis, specifically argumentative dimensional analysis. So the meaning of argumentative dimensional analysis simply means those dimensions that experience a situation whereby they are added at the same time they are being multiplied. So the only concept you're supposed to use in that case has to be the concept of argumentative dimensional analysis. This simply means there are some arguments due to the fact that you are adding, multiplying, subtracting, or dividing at the same time. A good example is this. Suppose you've been given dimensions that are written in this format. Then you have A, then you put a subscript or say small letter A, then plus you have B, subscript small letter B. You also have C, a subscript small letter C. A question may come whereby they are going to tell you to say if A, B, C, D are dimensions, suppose this, that, and that one are dimensions, what are you supposed to do for you to come up with the dimensions of these capital letters as constants? What do you do? In all the situations that are coming in this format, whereby you want to come up with the dimensions of the capital letters A, B, C, having been given these as the quantities that will be having dimensions, what do you do? So according to argumentative way of dealing with dimensional analysis, the thing you're supposed to do is we always equate the dimensions on the left hand side to what you have on the right hand side. How do you equate? In this case, we are going to equate x as a dimension to a subscript small letter a. You can also equate this x, you take it to capital letter B, subscript B, and finally we are going to equate again C, subscript C. In short, when using argumentative dimensional analysis, the thing you're supposed to do is equate what is on the left hand side to every independent quantity on the right hand side. Then if you've been given the dimension for this and dimension for that, all what you can do is you're supposed to divide this into that, it will give you the dimension for that. Suppose this was to be time. If this was time t and that was displacement, you need to understand that displacement is measured in meters and time is measured in what? Seconds. Meaning that for us to come up with the dimensions for A, all what we are supposed to do is, I'll say A has to be equal to what? X over A. Knowing that x has to be displacement measured in meters, and also a, which is time, has to be measured in seconds. So this is how you deal with argumentative way of dealing with what? Dimensional analysis. You put the dimension for this and put the dimension for that. Same applies if two quantities are arranged in this format, whereby maybe a is a dimension plus k, which is not having dimensions, open bracket, then b again is having dimensions, I'll say minus z, which doesn't have dimensions. How do you handle this kind of a situation if you want to come up with the dimensions of k? So all what you need to do, if there is multiplication in the middle, here we have addition, there we have subtraction. All what you can do is equate what is here, you equate this to that, and also equate this to that. As simple as that. That is how you come up with the correct answers when it comes to argumentative dimensions. Let's try to have two examples that will help us understand what it means by argumentative dimension. Our first example says a student derives a kinematic formula for velocity: v of an object that varies as v equal to a t square plus bt plus c, where v is the velocity and t is a time. Determine the dimensions of the constants a, b, and c, then get their units. So what are we supposed to do? Since this kind of a question is what we call argumentative, or it involves arguments, because there is multiplication of quantities at the same time there is addition, that's what we call argument. The moment you come across such type of a question which involves multiplication between two quantities, at the same time the multiplication of these two is added to the multiplication of the other, the multiplication of the other quantities, or what you need to do is we are using the argumentative rule. And how do you apply the same concept? So in short, here the thing you're supposed to do is we need to equate what is on the right hand side to what is on the left hand side. That's what the principle of homogeneity is telling us. So what are we supposed to do in this case? I'll say using the principle of homogeneity. Don't forget to write this. All right, if you are able to write it in that way, what are we supposed to do next? The thing that we are going to do next in this case has to be, we need to know the dimensions. Which dimensions are we talking about? We are going to take the dimensions of the quantity which is having dimensions. In this case, I think time must have dimensions, as well as the velocity to also have the dimensions. So v, which is velocity, is measured in meters per second, meaning that its dimensions will be L t to the power negative 1. Take them like that. Then time is measured in seconds. The dimension has to be capital letter T. Now we are saying if you are applying the principle of what we call argumentative rule, what do? We always equate this to all the quantities on the right hand side. How? We are going to have v equal to a t square. We are going to have v equal to b t. At the same time, we are going to have v is equal to c. This actually simply means c will just have the same dimensions as those for what? For velocity. So I'll say c, it must have the dimensions as l t to the power negative 1. So these are the dimensions for c. Since you want to come up with its SI units, if you check, c will always have the SI units as what? Velocity. So meaning that the SI units for c are supposed to be meters per second. Very simple and straightforward. If you come to b, what are you supposed to do? We know the dimensions for this. We also know the dimensions for what? For that. Meaning that b has to be equal to v over t. What are the dimensions for this? It has to be equal to what? L t to the power negative 1. You divide this by t. So the moment you take this on top, remember using indices, t to the power 1 multiplied by t to the power 1 gives us to give us t to the power 2. T to the power 1, or say t to the power 2 divided by t to the power 1. This is the same as t to the power 2 minus 1. What about t to the power negative 1 divided by t to the power 1? This automatically is the same as t to the power negative 1 minus 1. That's what we are going to get. B has to be equal to LT. So if you take this in that format, you will understand that it will give you negative 2, meaning that the SI units for B has to be what? Meters per second square. I believe this is something which is very much clear. Okay, let's try to get the dimensions for A. For A has to be equal to V over T. t squared. So this one, a has to be equal to v is l t to the power negative 1. Then t, which is squared, will just be like this. Take this format that way, you will find that a will give you the dimensions as SI units. A will just be the same as meter per cubic second. That is how you deal with argumentative dimensional analysis. Just equate the left hand side quantity to all the quantities you have on the right hand side, then get the dimensions. Let's try to handle the second question. All right, welcome back. Question number 2, or rather example number 2, is saying in the gas equation, which is given there, where P is pressure, V volume, and R is just a universal gas constant, T is given as temperature. What are the dimensions of A and B? So try to recall the limitations for dimensional analysis. We said all the constants will always have dimensionless. Certain things again, like temperature, we said it must also have no dimensions, it will be dimensionless. So since we are dealing with argument, what are we supposed to do? The thing we are going to do is just equate what is inside the brackets. Here we are supposed to be equating what is inside the brackets. Why? Because the right hand side part is just 0. So we are going to equate these two that are inside the brackets. Same applies even here. We are supposed to equate what is inside the brackets. We are supposed to equate what is inside the brackets. Ignore the sign. Whether you have negative, you have positive, just ignore it. All what you need to do is equate these two, that ignore the sign which is in the middle. So how are we going to handle this? How are we going to handle this? At the end of the hour, we are going to end up having P is equal to A over V squared and V equal to B. So I'll write using the principle of homogeneity. If you write this, it shows that you're trying to equate what is on the left hand side to what is on the right hand side. I'm saying for this kind of equation, since all these are dimensionless, equate what is inside the brackets. This to that and this to that. Ignore the signs in the middle. Whether you have negative or positive, just equate them in that way. So let me try to get the dimensions here. What are the dimensions in this case? So the dimensions that we are going to have, we need to start with pressure. Pressure is measured in force per unit area. So force per unit area, what we are going to understand is force is just the same as kg, meter per second square, and area is the same as what? Meter square. So this and 1 of m there will go. At the end of the hour, pressure is going to be capital letter M, then L to the power negative 1, T to the power negative 2. These will be the dimensions. Why are we doing that? Is because this one is mass M, then this one, if it goes on top, it will be L to the power negative. We come to volume. Volume is measured in meter cubed. The dimensions, very simple and straightforward. So we have volume there, we also have volume somewhere there. Pressure is there, we want to get A, meaning that A in this case has to be PV squared. So A is going to be equal to dimensions for pressure M, L to the power negative 1, T to the power negative 2. Then I'll take this L to the power 3, it has to be squared. A has to be equal to M L to the power negative 1, T to the power negative 2 dot. If you square this, you're going to have something like that. Now the concept is we have this guy and that guy. A has to give us M. These two, I think you need to know that they're supposed to give you something like that. And these will be the dimensions for what? For A. If you come to B, I think it's just the same as B. And that's how you get these same things. So keep on practicing a lot of questions that are falling under argumentative dimensional analysis. Don't forget to like, you share the video, try to subscribe to our channel if it's your first time as we're waiting for more videos to come. Bye bye.